Every public API eventually needs protection. Without rate limiting, a single client can overwhelm the system, whether intentionally or accidentally. The question isn't whether to limit requests. The question is how. The simplest algorithm is the fixed window counter. For every user or API key, you keep a counter and a time window, such as 1 minute. Each request increments the counter, and when the counter reaches the limit, further requests are rejected until the next window begins. The problem is the boundary effect. A client can send 100 requests at the end of 1 minute, another 100 immediately after the next minute starts. Even though the limit is 100 requests per minute, the system briefly experiences 200 requests in a few seconds. Sliding window counters improve fairness by considering a moving time interval instead of fixed boundaries. One implementation stores timestamps for recent requests and removes timestamps older than the allowed window. This produces much smoother limits, but requires more memory and computation. Another popular approach is the leaky bucket algorithm. Imagine requests entering a bucket that leaks at a constant rate. Even if requests arrive in large bursts, they leave the bucket at a steady pace. This effectively smooths traffic and prevents sudden spikes from reaching the backend. The token bucket algorithm works differently. Tokens are added to a bucket at a fixed rate, and every request consumes 1 token. If tokens are available, the request is allowed immediately. If the bucket is empty, the request is rejected or delayed. The important property of token bucket is that it naturally supports bursts. If a client hasn't made requests for a while, tokens accumulate in the bucket. The client can then spend those saved tokens to make a burst of requests without violating the long-term rate limit. There is no universally best rate limiting algorithm. Fixed window counters are simple, cheap. Sliding windows provide fairness. Leaky buckets smooth traffic. Token buckets support bursts while still enforcing an average rate. Choosing the right algorithm is really about deciding which behavior your system needs under load.